Recall the types of alloys and how they relate to atomic size. An alloy is a solid mixture of elements that exhibits metallic properties. The type of alloy formed depends on the relative atomic sizes, radii, of the component atoms. Substitutional alloy forms when the two mixing elements have atoms of comparable size, radii within about 15% of each other. The solute atoms directly substitute for the solvent atoms in the host metallic lattice. Interstitial alloy forms when one element has atoms that are significantly smaller than the other, typically less than 60% of the host atom's radius. These small solute atoms fit into the interstitial spaces, gaps, or holes between the larger solvent metal atoms in the crystal lattice. Determine the relative atomic sizes of nickel, Ni, and boron, B. Nickel, Ni. A period 4 transition metal with a relatively large atomic radius, approximately 124 picometers. Boron, B. A period 2 metalloid with a much smaller atomic radius, approximately 88 picometers, due to having only one occupied core electron shell, 1s to the power 2, shielding its valence electrons. Classify the alloy type. Because the atomic radius of boron is significantly smaller than that of nickel, boron atoms are physically too small to substitute for nickel atoms in the regular lattice. Instead, they must fit into the spaces between the closely packed nickel atoms. Therefore, a nickel-boron mixture forms an interstitial alloy. Identify the matching diagram. Diagram A, represented in the first visual, depicts a closely packed lattice of large, unshaded spheres with smaller, shaded spheres nested snugly in the gaps between them. This is a perfect particle-level representation of an interstitial alloy, where the large spheres represent the Ni host lattice and the small shaded spheres represent the atoms occupying the interstitial spaces. Thus, option A is the correct answer. The correct answer is option A.